Dalton's law of partial pressure states that the total pressure in a mixture of gases is equal to the sum of the pressure of the individual gases, which means that if you have a mixture of gases and you need the total pressure, if you know the individual parts, you simply add them up and that gives you the total. There are basically four types of problems that you encounter with Dalton's law. The first is by far probably the easiest problem that you'll work in chemistry, and that's when you're given a mixture of gases, they give you the individual parts and ask you for the total. And anytime that you're asking for the total, you're finding the sum. Sum just means to add. So this reads there are three gases in a tank. Gas A has a pressure of 1.5 atmospheres. Gas B has a pressure of 3.0 atmospheres. Gas C has a pressure of 1.0 atmospheres. What's the total pressure in the tank? And like I said, when you're just finding the total, you simply add them up. Gas A has a pressure of 1.5 atmospheres. Gas B has a pressure of 3.0 atmospheres. And gas C has a total of 1.0 atmospheres. You simply add 1.5 plus 3 plus 1, and you get a total of 5.5 atmospheres. Now the second problem that you'll be asked for, the second type that you'll encounter, is when they give you the total pressure and they ask you for one of the parts, like example 2. A mixture of nitrogen, oxygen, and argon gases in a container has a pressure of 800 millimeters of mercury. If the pressure of the oxygen is 200 millimeters of mercury and the argon has a pressure of 100 millimeters of mercury, what is the pressure of the nitrogen? And this is just the opposite of the previous problem, where you simply take the total and instead of adding things together, this time we're going to subtract because we know the total, we know all the parts but one. So the total pressure here is 800 millimeters of mercury. Minus the pressure of the oxygen, which is 200 millimeters of mercury. Minus the pressure of the argon, which was 100 millimeters of mercury. Sorry about that. So 800 minus 200, 600, minus 100 is 500 millimeters of mercury. Okay? The third type of problem is when they give you what percentage of the gases is something. Like in this particular problem, it says a mixture of gases has a pressure of 1.6 atmospheres. 75% of the gases are nitrogen. What is the partial pressure of the nitrogen gas? With this type of problem, you take the total, 1.6 atmospheres, and you multiply that by the percentage in its decimal form. And of course, if you have 75% to get to the decimal form, that just means you slide the decimal 2 places to the left. So 1.6 times 0.75, and you multiply that together, and you get that the partial pressure of the nitrogen is going to be 1.2 atmospheres. Here again, not difficult. Now, before we go to the fourth and final type of problem that you will run into with Dalton's law, I have to show you how to find what we call the mole fraction. It's simply the number of moles of the part that you're trying to find divided by the total number of moles of gas in a container. So if I'm given that I've got 2 moles of nitrogen, 4 moles of oxygen, and 2 moles of carbon dioxide, and I want to know what the mole fraction is for the oxygen, say, for example, well, it's going to be 4 moles of oxygen divided by the total number of moles. Well, the total number of moles here is 2 plus 4 plus 2, which is 8 moles. So then my mole fraction is going to end up being, and this is a reduced mole fraction, 1 over 2, or 0.5. Now, what you do that with this in your problem is if you're given the number of moles and a total pressure, and you're asked for which part of the pressure belongs to that individual gas. Well, first thing you do, you find the mole fraction, and you're going to multiply that by the total pressure. So in this example, it says that there are 2.5 moles of gas A, 3.5 moles of gas B, and 4.0 moles of gas C in a tank that has a pressure of 1200 torr. What is the pressure from gas A? Well, to get the mole fraction, it's the part. For gas A, I've got 2.5 moles. We're going to divide that by the total number of moles, which is 2.5 plus 3.5 plus 4.0. So 2.5 plus 3.5 plus 4.0 is 10 moles. So I'm going to take 2.5 divided by 10, and I'm going to multiply that by the total pressure, which was 1,200, 1,200, or 1,200 torr. So when I do this right here, this would actually reduce to 1/4, if you will. And with that said, 0.25, or 1 over 4 times 1,200 will give you 300 torr. And that's about all the questions that you're going to see at this level with Dalton's law.